So guys, we are going to create a site to site. So we have taken 3 routers over here, and in 3 routers, one router will act like a ISP. So this router will act like a ISP, and these are the two routers between which we need to create the tunnel. So let's put the public IPs, I mean like public subnet between R1 and R2 and R2 and R3. So between R1 and R2, I'll put 192.1.12.0/24. This is 1 and 2, so I'll accordingly put 12.0, and this is 2 and 3, so I'll put it as a 23. So this is what your IP addresses will be. See, IP addresses will be according to your router numbers. On R1 we'll put it .1, on R2 we'll put a .2, and on R3 we'll put .3. And on the R1, I'm going to create a loopback. So I'll say interface loopback 1, and IP address I'll create as a 10.11.11.1/24. This is my loopback as a private IP that will be testing. So our actual traffic, our interesting traffic will be 10.11.11 to the other side 10.13.13.3. This is our interesting traffic. Guys, interesting traffic means our tunnel traffic. I'm talking about the tunnel traffic. Okay. Let's say, for example, I'm going to create a tunnel over here between R1 and R3. Our tunnel will be like this. This is where we are going to create a tunnel. Okay. So through the tunnel, when we'll be communicating between 10.11.11.1 to 10.13.13.3, this will be my interesting traffic. This is my tunnel traffic or interesting traffic, whatever you call it. Okay. So whenever any traffic is passing through the tunnel, let's say from here it will be requested, and through the tunnel we'll be sending the traffic, and it will reach to the other side. Okay, and this is how the communication will happen. Okay, guys, understand one more thing I'll be adding here. We are going to create a policy based. It's a policy based site to site, not a routing based. Policy based. I hope you guys remember what's a policy based, right? Tell me guys, what is policy based VPN? What happens in the policy based VPN? What ACL? Simply telling ACL, what ACL?
So yeah, we will have an extended access list, and when it matches the policy, we'll get to it.
We need to match our interesting traffic. Okay, let's create configurations on the R1, R2, and R3. So always make a habit of using Notepad, guys. Okay, so here I'll say initial configurations I'll create. It's on R1. Enable configure terminal host name. I'll put it as a R1. Interface G0/0 with the IP address as a 192.12.1/24, and I'll say no shit exit Yes. Okay. Now here I'll create a loopback interface loopback 1 with the IP address as a 10.11.11.1 with the subnet mask as a 25 sorry 24. I'll say exit and I'll create a default route. Tell me guys what will be the gateway for R1, the ISP IP IP route 0.0.0.0. Tell me what's the gateway IP for R1? What's the gateway IP for R1? Tell me. Correct. So according to the router number, we'll have the IP address 192.1. It's 2L.2. Correct. Now, this is the quick configuration done on the R1. Quickly copy this and paste it over here and edit it for R2. So here the IP address for G0/0 interface will be .2 and here we'll take interface G0/1 with the IP address 192.1.23.2 with the subnet mask of 24. Your ISP is directly connected to both the public subnets, so I don't need any kind of routing over here. This is enough. Again, paste the configuration, put it R3, host name R3, IP address will be 23.3 and the loopback will be 10.13.13.3 and the gateway will be 23.2. This is the configuration. So let's quickly configure and check the reachability. I'll take the console of these devices, say no, no, and say no. Let me increase the font size. Okay. So I'll copy these configurations and I'll paste it on respective devices. R3, paste the configuration. थोड़ा गर्म पानी ले आना. I'll take the configuration for R2. And the configuration for R1. Okay. Once this is done, then we'll check the connectivity. Guys, always remember while creating any type of VPNs, no matter what VPN it is, always remember one mantra that you should always check the reachability first thing. Before you do any type of configurations, please check a reachability between the two sites. Between the public IPs, you should check a reachability before you start any configurations of your VPN. Because if your routing itself is not good, then your VPN will never get up. So very first thing, this is the first thing that you should remember. Check a reachability between the public IPs and then only start the configuration of VPN. So see here, I'll come to R1 and let's check the public IP. So what public IP should I check, guys? From R1, what public IP should I check the reachability? Tell me, what's the public IP? R3 public IP, correct, not R2. Directly check R3, in between R2 will get checked automatically. So 192, I'll try to ping 192.1.23.3. It's a reachable. So you are good to go. You'll not be able to reach right now. Let's say, for example, guys, I want to ask you one thing right now. Right now, if I'm sending the reachability, if I'm trying to send the ICMP packet to 10.13.13.3 with the source as my loopback 1, then where exactly your packet is getting dropped? Where the packet is getting dropped right now, guys?
The ISP.
On your ISP, packet is getting dropped, right? Okay, good. See here. So IP route, if you see this, what do you find here? You find any route, I mean like any network with any mask, the packet will be forwarded to the gateway, that's my ISP. It means right now any traffic that we are sending, your edge router, your edge device is sending that packet to ISP directly. That's why the packet, when it reaches to ISP, ISP drops the packet for the private communication. If you guys see here on the R2, if I say debug IP ICMP, and if I try to communicate between these private networks, you will see the packet reaching here, but the packet is not reachable to this particular destination because ISP does not have a route for the private IPs. If you check the routing table, so IP route, you can see there is no route for the private IPs. It means your ISP is dropping the packet. So our task is, I'll not send a traffic through ISP. Rather, I'll create a tunnel between the two sites over the ISP, and I'll be communicating via tunnel. That's our target. I'll be communicating via tunnel from one site to another site. That's our target. Okay. So I want to communicate through the tunnel. So let's create the configuration. So very first thing, you guys need to create a phase 1 tunnel. So our first task is on R1, I'm going to create a phase 1 tunnel. So let's create the phase 1 tunnel. I'll say crypto ISACAMP policy, and you guys can give any policy number over here. See, these policy numbers will matter when you have a multiple sites to communicate, right? Then your numbers, this policy number will make the priority to the protection suite. Okay, whatever it is written here, that's all about if you have the multiple sites to communicate. Now let's say, for example, on R1 I have multiple interfaces, and each interfaces I am communicating with the multiple sites. For this interface, it's a site to site. Similarly, for another interface, I have site to site, another interface, I have site to site. In that case, if I want to prioritize which policy has to trigger for which site, in that case, these policies will matter. Okay. But if you don't have such type of conditions, then you can give any kind of number, does not matter. Now, inside this, you guys have to define all this Haggle process: authentication, encryption, group, hash, lifetime. Right, sorry? Anyone telling something? Okay. Now, under the ISACAMP, we will be defining all these Haggle things. Now, I'll say authentication method. I'll be following. See, you have a different authentication methods. You can see we have a pre-shared key, we have the RSA method. We'll also see RSA method. We have the upcoming VPN called as a CA certificate based VPNs. There we'll see how we'll be using the RSA signatures. but as of now we are going with the pre-shared key. Okay, so I'll give the authentication as a pre-shared. Encryption, press the question mark. You can see multiple encryption algorithms we have. We have a 3DES, we have AES, we have a DES. I'll recommend you guys to go with the AES because DES and 3DES has been already outdated in the market. Your 3DES also has been cracked by the hackers. So do not use a 3DES or do not suggest for 3DES anymore in the market. Go with only AES or the advanced encryption system. That's what we call. Now, you can choose what will be the bit size of your AES. You can choose either you want to go to 128, you want to go with 192, you want to go with 256. It's up to you. Let's say I want to go with 192. Press the question mark. Does not give you the another option to define the key sizes. Now, one thing keep in mind, guys, when we'll be talking about the IKE V2, remember, further classes will do for the IKE V2. In IKE V2 on the Cisco devices, okay, IKE V2 in the Cisco devices like router and the switches and all, you will see you'll have the multiple options for the encryptions, multiple options for the authentication. I mean, like for all the Haggle process, you will see multiple options you will have. But in IKE V1 on your Cisco routers or the switches or the firewalls, you don't have the multiple options to choose the key sizes over here. But when it comes to the Palo Alto, when it comes to the checkpoint, you do have the multiple options. You can define the multiple algorithms over there, right? More than one algorithm you can define, but here you do have the option of only one algorithm. Okay, now encryption done. Now I'll choose the hash. Okay, when you say hash, press the question mark. You can see here. Now what's the hashing method you want to choose? You can go with MD5, you can go with the SHA. So minimum go with the MD5 or SHA, or others is your choice. So authentication, encryption, hash, right? I'll define the group. Press the question mark. You can see you have the multiple grouping options. Let's go with the def element group 5 over here, and a lifetime. When you press the question mark, you can see the maximum lifetime that you have is 86,400 seconds, and minimum you can put as a 60 seconds. That's your 1 minute. So guys, should I define 86,400 seconds as a lifetime?
No, that's a default.
That's a default, correct. If I define it, does not matter. If I don't define, still it takes the same lifetime. So we defined the group, encryption, hashing, authentication, lifetime, all this stuff. Now, let me take the history. If we get it, do show history. This router does not give the history. Okay, let me copy all these commands. See guys, in short, you guys can write crypto ISACAMP policy, give number as a 10, say encryption as a AES, it was 192. We had the hash of SHA. We had the authentication as a pre-shared key, and we had a group as a 5, right? And we had the authentication, and we had a lifetime as a 86,400. Try to use as short command you can use. Okay, as much short command you can use. That will help you to avoid the spelling mistakes. Now we'll define the phase 1 authentication. Remember guys, we are going to divide all the configurations into 5 parts. So this is my step number 1. It's my step number 1. Total 5 steps will differentiate the entire command. Now this is your step number 1. In this step number 1, we'll be defining all the proposals, and also we'll define crypto ISACAMP key followed by 0, and my key will be Cisco 123 with the destination address. You'll define destination address as what's your public IP, guys, with whom you're trying to create a tunnel. What's your public destination IP with whom you're going to create a tunnel?
R3. R3 G0 by 0.
R3. So we'll define the R3 public IP. So here we'll put 192.1.23.3. That's my public IP. Remember one thing, this is a phase 1 complete step. And this is what you're defining, is you're basically defining the gateway. This is basically you're defining the gateway. It's a gateway for phase 1. You're telling with whom you're going to establish the tunnel. All right, this is my phase 1 gateway as well. You are defining the phase 1 gateway. In other vendors, they will call it as a phase 1 gateway because I'm defining to whom I'm going to create a tunnel. Right. So this will be known as a phase 1 tunnel. Now, step number 2. I'm going to create a step number 2. That's my phase 2 tunnel. I'm going to create a phase 2 tunnel. Phase 2 tunnel. Now guys, you remember in IPsec, I told you in IKEV1 phase 1 is known as, what's the term given for the phase 1 in IKEV1? In IKEV1 phase 1 is known as, what is the term given for the phase 1 in IKEV1? What is the term given for the IKEV1 phase 1?
It's a key exchange.
Little louder.
Is it the, you mean, can you be more specific, sir?
I'm talking about in IKEV1, we have phase 1.
Right.
Right. That phase 1 has some term, it has some name. What's that name?
Is that ISACAMP phase 1?
That's a correct answer. See, ISACAMP is basically the term, the name given for the phase 1. Right. But what is the role of phase 1? That's a control plane. What is the purpose of phase 1? It's a control plane. Right. But in general, we have some term that we use for the phase 1. Right. So you remember, I'll show you. Wait. Do you remember this part? I told you in IKEV1 we have 2 phases. Your phase 1 is known as a ISACAMP. The term wise it is called as ISACAMP, and phase 2 is known as a IPsec. Right. The purpose of phase 1 is to exchange the key, and basically it is also called as a control plane. Phase 2 is used for the real data communication. Right. But the term is given as the IPsec, but the phase 2 is used for a data plane. Right. Guys, are you getting my point, what I'm saying? Technically, what we call this phase 1 and the phase 2 in IKEV1?
Yes.
Is that clear now?
Yes.
Okay. So this is what I was asking. Now, why did I ask you this question? There was a reason. Now, based on these terms, you can remember the commands. and it's like technically how you remember the commands. Now, do you see, like when I created the phase 1 tunnel, I started with the keyword as a ISACAMP. I said crypto ISACAMP policy, crypto ISACAMP key. I haven't used a full word over here, right? But it is ISACAMP. ISACAMP. I used ISACAMP as the keyword to define the phase 1 parameters. Now, when I start the phase 2 parameters, you will see in my configuration, it will be written as a crypto IPsec. Now, these terms will help you to understand. It will help you to correlate with the phases that we have named in our IKV1 and IKV2. And this will also help you to write the configuration for phase 1 and the phase 2. So crypto ISACAMP, crypto IPsec, right? Transform set. What's a transform set over here? What's a role of transform set? The role of transform set is to define the phase 2 parameters. I'll be defining phase 2 parameters. I hope you remember, for phase 2 also we need encryption and the hashing. And the key that will be used to encrypt the phase 2 tunnel will come from where, guys?
Phase 1.
The key which will be required to encrypt the phase 2 tunnel will come from?
Phase 1.
Correct. So here I'll define ESP. ESP with, you can define what type of algorithm you want to define here. Let's say ESP, and we'll define ESP with, you want to go with what type of algorithm. Let's say, let me define this. After that, let me take this and press the question mark. You can see it is asking you for the tag. Tag means it is asking you for the name for the transform set. So let's say I'll give the name as a T set. After that, press the question mark. You can see you have a huge list of encryption and the hashing. Now, one thing you need to pay attention here, you can see AH, AH, AH. Now, all the AH, wherever you see only MD5, SHA 256, SHA 384, SHA 512. Is there any encryption algorithm with the AH right now?
No.
All these algorithms, what you see, which algorithms are this?
The hashing.
These all are the hashing algorithms. These all are not the encryption algorithms. So by looking at this part also, you can identify that AH does not support the encryption. It supports only the hashing. After that, wherever you see this part, you can see everything. ESP with 3 dash means hashing. ESP with AES means, encryption, not hashing. ESP with 3 dash encryption. ESP with AES encryption. ESP with dash encryption. So in this way, you guys can see all the encryption algorithms over here. Now, even you see ESP with MD5, ESP with SHA, ESP with SHA, all the varieties you have. So you can choose anything. So let's start with ESP protocol, and ESP with, I would go with AES. Again, ESP for the hashing. So let me go with the SHA, HMAC. And one more thing today I'm going to tell you about the tunnel. When you define the IPsec as a, the protection to the tunnel, your IPsec will have 2 modes of a VPN. Remember, your IPsec has 2 modes of a VPNs. Just here I'm telling here, your IPsec has 2 VPN modes. Can anyone tell me what are the 2 VPN modes in the IPsec?
The phase 1 we have main mode, and the phase 2 we have quick mode.
Your voice is very low.
Can you hear me now? Hello?
Yes, I can, please.
Okay, in the phase 1, we will have main mode, and phase 2, we have quick mode.
No, that is, those modes are basically phase one or the phase two,
Okay,
having main
okay,
mode and the quick mode. Those are different
okay,
things.
you're
I'm
talking
talking
about the
about the
phase.
VPN mode. Okay,
Okay, the tunnel and the transport mode you're talking about.
correct. So when I ask you what's a VPN mode, I didn't ask you about the tunnel modes. Okay,
Okay,
so
clear, clear.
when I say VPN modes, the VPN modes are basically tunnel and transport. These are the two different things that you should answer. Whenever in an interview they'll ask you, see, you have to be very confident and you have to be very careful about what they are asking you. Are they asking you what are the IQ modes? If they're asking you IQ modes, then you will answer about phase one, I mean like main mode, aggressive mode, quick mode, those things. Right now, my question was, what are the IPsec2 VPN modes? Right. So I specified two VPN modes. Right. It means the modes that are present in a VPN configuration with the IPsec. It's tunnel and the transport. Now, what's the meaning of tunnel and what's the meaning of transport? Tell me.
Mm, the
See, when I talk about
encapsulation.
tunnel, this is the default mode. It's a default mode of your IPsec. And when you have to configure a transport, you have to manually transport mode, you have to configure manually. This should be configured manually. Now, what's the use of tunnel mode and what's the use of transport mode? With the
Encapsulation will be
transport mode,
different.
your packet size will be reduced. Okay, that's a logical answer, Abhishek, but I need a practical answer.
The encapsulation will be different in both the modes. This is
Okay,
what I know.
let me tell you guys. Let's say I have a data. On the top of data, I'll have the private IPv4 address, IPv4 address, right? And on top of this, I'll have the public source, public destination, right? Now let's say here on top of this, these all informations will be encapsulated, and on top of this, I'll have the public source and the destination, right? So basically what I'm going to do is I'm going to encrypt the entire data. This entire data I'm going to encrypt. This entire information I'll assume it as a, let's say for example, this entire information will be assumed as the your information as a datagram part, and on top of this I'll be adding the public source and the public destination. Now let's say for example there is only a private, there is a private source and the private destination, and there is a data. Now let's say in between this I don't have the another IPv4 header. I want to encrypt only this data part. I don't want to encrypt the IPv4 header part. Now it can be this way also. Let's say I have the, the public, whatever the IP header part you have, right? See, it can be an additional header part also, right? This thing will be more clear when I'll talk about the GRE header. In a GRE header, what happens? I'll show you. Actually, you'll have the public IPv4 header, and uh, you'll have the data, you'll have the private IP, you'll have the public IP. Okay, I mean like public IPv4 addresses you'll have for source and destination. Now here also we have the private source and destination. right? Now currently in a tunnel mode, what is happening? This entire data they are assuming it as a data, and on top of that they are adding the public source and the public destination to route the packet. Now in a GRE mode, what will happen? There will be a condition wherein these two datas, I mean like this, both the headers, private IPv4 header and your public IPv4 header, this entire will be assumed as a data, right? This entire will be assumed as a data. When we'll see a GRE tunnel, in a GRE tunnel, what you will see, this entire information will be assumed as a data, and again on top of this you will see ESP or AH header added, and on top of this you will see a public source and public destination getting added, right? So basically whatever the data we were having previously to communicate, and including with the public address, the entire information will be assumed as a data, and on top of this the encapsulation will be done, and on top of that again the source and the destination, I mean like public source and destination will get added. So there is a repetition of the public headers. If your public headers are used to send the packet from the source to destination, then what is the use of another public header again? There is no use of the same source and the destination. So if I want to remove this repetition of the header which is inside the encapsulated packet, or I want to assume the the encapsulation from here itself, I want to remove this repetition of the IPv4 header, then I would use the transport mode. So the same packet, when you take it inside the transport mode, right, for the GRE header, when you take it, then what will happen? This repetition of the IPv4 header will be removed, and you will see these many packets only getting encapsulated, and on top of that this public source and destination getting added. So in these conditions, in such conditions, the transport mode will be used. Or I'm telling you, or one more condition is there wherein transport mode can be used. There is or condition. Now let's say for example you guys have the VPN called as a get VPN. You will see one example as a get VPN. This get VPN we basically use to encrypt our intranet network. What's my intranet, guys? What's my intranet? What do you mean by intranet?
It's a communication within the private network.
It's all about our internal network, right? Intranet with our local network. Now let's say, have you ever guys thought about, like, when I'm communicating within my internal network, when I'm communicating within my internal network, right? So in my internal network, when I'm communicating, the data what is transmitted between these two devices or three devices, this is my internal network. Here I have the ISP, right? And again on the other side I have the other sites. So right now I'm talking about this part. I'm not talking about the tunnel creating over the internet, not this part. I'm talking about the communication that I'll do in my internal network. So basically currently we are thinking about how to encrypt the traffic over the internet, but we never think about our internal communication. In our internal communication, whatever the traffics will be there, whatever the IP addresses will be there, that will be my LAN network, right? And in my LAN network, whatever we have an IP addresses, we are aware of that, right? Guys, reply me. Whatever the IP addresses will be used in my internal network, we all are aware of that, right?
Yes, yes.
So I don't have another public header to carry the information. So we have only two things. We have a data and we have the public IP. We have the private IP. We don't have another header to carry the information. So in this case, when you use the transport mode, then what will happen? It will encrypt this data part, not the IP part. So it's basically not encrypting your IPv4 header. If you have two IP headers, another IP header you have, then till this part it will assume it as a data. Understand? Till this part it will assume as a data. If you have a single IP header, then this part will also only be assumed as a data, which will be encrypted in the transport mode. Guys, are you understanding what will happen in the transport mode?
So let me ask you something.
Yeah.
So you mean when we use a transport mode, on the outer side, on the layer 3 side, in the OSI model, we will have the public IP addresses.
Correct.
And then we have the ESP. Then the ESP will encapsulate the private IP plus the data. Is that the transport mode? Okay, clear. Okay, correct.
Now, let's see the other part. Now, we understood there are the two modes. Now, where exactly these modes can be changed in your VPN configuration? Now, this is the part which I was talking about. Okay. So when I create the phase 2 tunnel, guys, when I create the phase 2 tunnel, in this phase 2 tunnel, you will see here on the R1, I was creating a phase 2 tunnel. So here I'll say crypto IPsec transform set as a T set and press the question mark. We'll go with ESP encryption algorithm with the AES, and we'll go the hashing algorithm with the ESP with the SHA hatchmack. Press enter, and if you press the question mark, here it says you mode option. Mode is used for what? Encapsulation mode, right? Encapsulation for what? Either it is a transport mode or it's a tunnel mode. Now, if I go with the mode, press the question mark, here it says transport is basically payload encapsulation, but the tunnel is datagram encapsulation. If you guys at least give these two differences of the VPN modes, right, then you will be, selected. At least, I mean, like, these are the two valid reasons which you can give in the interviews. So you can say transport mode is basically used for payload encapsulation, and you can see tunnel mode is used for the datagram encapsulation. Guys, am I clear to everyone now?
So can you just tell me what's the difference between this payload and the datagram? How can we differentiate that?
See, what's a payload first of all?
Payload should be the data, right?
Payload is just like an envelope. Okay, it's like an envelope.
Okay, it can have data plus some other information, you mean?
Correct.
All right, now it's clear. The datagram is actual data.
A datagram is actual data, correct.
Okay, now it's clear. Okay, clear.
Okay, now if you want to change to transport, then only you will come to the mode over here. If you guys want the tunnel mode itself, then no need to do any modification over here. Simply come out of this. So this is the transform set that we created right now. In your interviews, these are the small questions they'll ask you. They'll not ask you, the big things. They'll not ask you how do you configure IPsec. No, never. They'll not ask you, tell me the other big stuffs. They are going to catch your small things, and then they'll try to know, are you aware of those basic things or not? Now, we are still into a phase 2 configuration, and that's my step number 2. Now, in a phase 2, we'll have the step number 3 now. Step number 3 will be to define your ACL. In a ACL, we'll be defining, guys, who is the actual, to whom we are going to communicate in a real communication. Your tunnel traffic, basically ACL here means your tunnel traffic. So what is our tunnel traffic, guys? Our tunnel traffic is to communicate between which IPs?
1011 and 1013.
Okay, so ACLs you can define again in two different ways. Either you can go with the numbered ACL or you can go with the named ACL. Okay, do not define the standard ACL, define the extended ACL only. So depends. So I'll say access list, you can define access list and press the question mark. Now I would go with the numbered ACL. It's up to you how you want to define. Right, now define, instead of here you'll define action, and here you'll define again what type of protocol you guys are going to select. Right, let's say I want to permit all the protocols. It's up to you. If you want to communicate only TCP based traffic through the tunnel, it's up to you. If you want to send only ICMP packet, it's up to you. You can limit the protocols inside the tunnel. Right, so let's say for example I'm giving IP over here, and now I'm going to give a source host as the 10.11.11.1 and 10.11.11.1 and destination host as the 10.13.13.3. Guys, two things you have to remember over here. If you are giving a particular host IP, then you have to define the keyword as a host. If you guys are defining subnet, then there is no host command, always remember. Now let's say if I want to define the subnet 10.11.11.0. so on the router, when you define the access list, what should you define inside the ACL? Subnet mask or wildcard mask?
So wildcard mask.
So 0.0.255. Your 0 means mind, 0 means mind, 0 means mind, 255 means non-mind, right? Now the other side, it's 10.13.13.0 with the 0.0.0.255. Give this. Now your ACL is ready. Now let me copy this and paste it on the notepad. Now guys, you have the fourth step. This transform set is my third step. Now I'll have the fourth step. And what's my fourth step? Is to collect all the above informations at one place. So we basically call that as a crypto map. I'll create a crypto map with some name, let's say C map, and press the question mark. Here you have to use ISACAMP with IPsec. Okay, first of all, give the sequence number. Guys, you remember at the beginning of this configuration I told you there is a number given for the ISACAMP policy. Remember, if you have the multiple sites and in that multiple sites you want to match the phase 1 and the phase 2 policy, remember, keep the crypto map number as the same. So if I put 1010, so both will match. But if you don't have multiple sites, then you can give any number over here. I can give 10 also, I can give 12 also, does not matter, it will work. But if you have the multiple configurations, then make sure if you want to match the policies phase 1 and the phase 2, please put the same number. And let's say we have 10 and then we'll use, press the question mark. Here you have IPsec, ISACAMP. Put this command and press enter. What does it give you the information over here? It says this new crypto map will remain disabled until a peer and the valid access list has been configured. So this parameters has to be configured. If you don't configure such things, your crypto map will not be functional. It means we need to collect all the informations. So very first thing, I'll define, it says your peer. So you will define the peer. So we'll say set peer. Under the peer, what's my phase 2 gateway, guys? See, phase 1 gateway we already defined. Phase 2 gateway will also be same IP 192.1.23.3. That's my phase 2 gateway. Now we'll define match address, and what's my access list name? 101. And the other third thing that you have to define is set. You have to set the peer we already defined, and we have to say set a transform set. So what's your transform set name? T set we define. So these three parameters you guys have to define inside your crypto map, or else your tunnel will not work. Set transform set as a T set, set peer as a 192.1.23.3, and match address as your 192, no sorry, 101. That's my ACL name. So these parameters you will define under the step number 4 under the crypto map, and the final one is the step number 5. You are going to apply it to the public interface. This crypto map you will be applying to the public interface. So I'll go to the public interface G0/0, and I'll say crypto map as a C map. This is how you apply it. Now guys, here you need to pay attention is you'll take the same copy, of this configuration. We call it as a mirror entry. Take the same configurations and paste it and make the configuration for the other side. Okay, so this will be the configuration on your R3. We call it as a mirror entry. So for the phase 1, all these parameters will put it same, and our destination will change. Your destination IP will become as a 12.1. In a step number 2, let all these parameters be same. Your ACL will change. Your source will become destination, and destination will become source. So 10.13.13 will be the source, and 10.11.11 will become the destination. Step number 4, your crypto map, everything let it be same. Here it will make it as a 12.1. ACL number is 101 itself, and we applied to the same G0/0 interface. On R3 also we have the same interface. Please make sure in your examinations that you should check these interfaces perfectly. Right, are they same interfaces or the different interface? You need to verify it properly. Now once this is done, then what we'll do, we'll quickly copy and paste this information on the R3. So let's copy this. See, if you have anything written over here, then you can bypass that step by writing the exclamation on top of that, right? And simply you can copy and paste after that. So I can copy and paste everything. Exclamation includes that it's not a command, it's simply the information. So copy and paste. Okay, once this is done, you'll see your phase 1 is ready for the negotiation purpose. I mean, like ISACAMP is ready means it is ready for phase 1 and phase 2 as well, right? ISACAMP contains both the tunnels. Now it's a time for doing a verification, guys. So we'll try to verify and try to check. We'll also capture the packet and see all those informations. So let me capture the packet at G0/0 interface. With the Wireshark, we'll try to capture and see. Now let's try to send the packet from one side to another side. You can make anyone as an initiator. Okay, so let me make R1 as an initiator. So I would like to ping from I would like to ping to 10.13.13.3 with the source as my loopback 1. I'm not able to communicate. Let me try again. Is it on R3 set peer? No, it's correct only 192.1.12.1. This is correct. ACL 101, that's also correct. 13.13.0 and 11.11.11.0, this is also correct. Crypto map CMAP is correct only. What is the problem? R1 crypto map. Let us check.
So can we put the show run crypto on the both routers and see if they're matching each other?
We'll do that. We'll do the verification, but right now I'm just checking what's the you can see here we used the same parameters 23.3, this is there. We can see 11.11.0 is there. This is fine. Transform set, AES, ESA, HMAC, everything is there. 23.3 is there. AES 192, all these parameters we have given the same one. That's only the reason that we should not have any type of issues with the configuration part. Only the few things will be changing. That's a 192.1.12.1, and this is the configuration. This is the configuration. Okay guys, let me do one thing. Let me say, you can verify the configuration also. Okay, so running section crypto, and the other side also you can put the,
you have no binding there in the other one. See, you don't have binding on the interface. Crypto map is not binded on the interface.
wait. So running interface G0/0 on R1, correct. I haven't applied it. I did the configuration, but I didn't apply it. So I have written here and I didn't apply that. So let's come to R1. Let me apply it. Okay. So you can see the ISOCamp is on. Now it's correct. Let's try it again. So try pinging. It's working fine. And here you can see this packets has been captured here. So guys, can you see? Let me stop the capturing now. Can you see here that we have an ISOCamp 6 modes over here, the phase 1 mode, and you have the phase 2 mode. Guys, can you see here that all the protocols for phase 1 and phase 2 is what? ISOCamp. Now, am I clear to this concept that the phase 1 and the phase 2 tunnel is carried by ISOCamp protocol, and after the phase 1 and phase 2 successful message exchange, then you can see the ESP packet getting exchanged. Is this clear to everyone, guys?
Yes, yes.
So no more confusion from here.
Can you please
Okay.
show me the ESP packet header, sir?
Yes, we'll
To see the
ESP packet. How come you'll see the ESP packet? Here you won't see anything. All the informations will be encrypted.
Yeah, correct. Okay.
Okay. So let's see all these 6 message
So
exchanges.
actually, so can you just show me that once again?
Yeah.
So actually, this and ESP is actually encapsulating our private IP inside this one, right?
Huh. See,
And
all the
so
informations here, whatever the data is here, all these informations will be encrypted. You won't be able to see anything. Okay, you
now
won't be.
we were discussing about the tunnel mode. So you said inside the security payload, we will have our private IP address getting encapsulated. I mean encrypted and sent.
Those all the info data and the private IP addresses informations all are encapsulated and encrypted under the ESP itself.
Okay. Okay.
Okay, and on top of that we have the public source and the destination. So that's over here. Now see this thing, you'll get the information. See, here you have the ISACAM protocol running on the UDP port number 500 for the source and the destination. And in the first packet, we can see only the SPI parameter sections from the initiator. We don't have the SPI parameter of the responder. And here you can see the next payload is your security association payload, right? And in this payload, you can see that we have the security association payload. Under this payload, we have the proposal payload. Under this proposal payload, we have transform payload, and under the transform payload, if you see, you have the another informations. Can you see all these attributes, IKE attributes? 192 SHA, Diffie-Hellman group 5, that's the key size 1536, method as a pre-shared lifetime 86,000. Guys, the same information you will see on the site, site 2's responding message. You can see here the SPI parameter is there. Now you can see the responder's SPI parameter, and again you can see it's a agree packet upon the transform attributes that was basically requested from the initiator. It has agreed upon same parameters over here. Now after this, we have the third message exchange. Message exchange, you can see that you have third message exchange. You can see you have the payload called as a key exchange. When you see here, you will see you have the data for the key, and you have the nonce payload, and the nonce payload also has a nonce data, and along with that you can see there is a NAT discovery message that is basically exchanged to identify is there any translated device in between or not. Now the fourth message exchange, again it will share the Diffie-Hellman key along with the nonce. You can see the Diffie-Hellman key, nonce data, and also you'll have NAT discovery. Now the fifth message exchange, once the key is exchanged between the two sites, after that the information that will be exchanged between the two sites, now the identification from one site has been sent, still the identification has not happened, the authentication has not happened, and that data has been sent in the encrypted format, but the data is encrypted, that is for sure, because the key has been already exchanged. Now the sixth message, if you see, in the sixth message you will see that the identification has also been sent from the responder to initiator, but the data was encrypted. After this message exchange, the authentication completes, and then the quick mode gets established. In the quick mode, I would like to show you guys. See, I clicked on the phase 1 first message exchange and the second message exchange. I want you guys to take a note of this SPI parameter. This SPI parameter of initiator and the responder. Take a note of this. Done? Now,
Yes.
when I come to the phase 2 tunnel, which is under the ISACAMP, do you see the same SPI parameters again? Do you see the same SPI parameters?
Yes.
Okay, so those are basically verified, and then the real data, it will exchange. Okay, after that, the real data what is getting exchanged here, you can see all are encrypted under the ESP. So ESP starts for the phase 2 tunnel, that's true, but it starts only after the quick mode when it completes. So this is how it works.